Welcome again to Math 800 Pre-Algebra. Today we are doing section 5.9, Problem Solving Equations Containing Decimals. Our objectives: 1. To solve equations containing decimals using the addition property of equality. 2. To solve equations containing decimals using the division property of equality. 3. To solve equations containing decimals using both properties of equality. And lastly, 4. To solve application problems involving equations with decimals. Example: solve the equation w plus 2.9 equals negative 0.6. We want to get the w, the variable, isolated by itself on one side of the equal sign. In this case, since the variable's on the left, we want to get it alone on the left. That means we need to do something to get rid of the addition of 2.9. There are two ways to think about this. One way is to think that you're adding a negative 2.9 to both sides, or you can just subtract 2.9 from both sides. The key is that you're doing the same thing to both sides of this equal sign. On your test and your quizzes, you must show me the algebra that you are doing the same thing to both sides of the equal sign. If you do not do that, you will not receive full credit. So now I'm adding a negative 2.9 to both sides. A positive 2.5 and a negative 2.9 add up to be 0. We don't typically write this, however, some students find it helpful. Negative 0.6 and negative 2.9 add up to be negative 3.5. I would strongly recommend that you do any arithmetic on the side of the paper so that it stays organized and neat and doesn't interfere with your actual algebra. W plus 0 we simply rewrite as w, since anything plus 0 is just itself, and then we check our answer. This part, the checking part, is optional. Excuse me. It's highly recommended, particularly on your quizzes and your exams. However, you do not get points for it, so on your exam, where you might run out of time, I would do all the problems first and then come back and check. So now we're going to check by replacing the variable with what we got for the answer, negative 3.5. Negative 3.5 plus 2.9 should add up to negative 0.6, and it does. Notice your answer is w equals negative 3.5. This was a check. It's not the answer. The answer is negative 3.5. I would also highly encourage you to include the w, or the variable, in your answer. Solve the equation 7 equals negative 4.3 plus x. Again, we want to get the variable alone. This time the variable is on the right side of the equal sign, along with a negative 4.3. We're going to add 4.3 to both sides. Again, you have to show me that you're doing it to both sides of the equal sign. 7 plus 4.3 is 11.3. Negative 4.3 plus 4.3 is 0. 0 plus x just winds up being x. So our answer is 11.3x equals x. Then check your answer. Put it back in the equation in the original situation, and you get 7 equals 7. Therefore, our answer is 11.3 equals x. It does not matter if your variable is on the left or the right of the equal sign. An equal sign means the thing on the left and the thing on the right are the same. So it doesn't matter which side they're on. Another example. This is for objective 2. Solve the equation 5x equals 12.4. Recall that 5x is the same as saying 5 times x. So in order to undo a multiplication, we are going to divide by 5. You can also think about this as multiplying by the reciprocal of 5, which would be 1/5. As long as you do it to both sides of the equal sign, you'll maintain your balance. So we're going to divide both sides by 5. On the left, the 5 divided by 5 cancels out and gives you 1. On the right, 12.4 divided by 5 gives you 2.48. Do any necessary long division on the side of your paper so it does not interfere with your algebra. Our final answer then is x equals 2.48. Again, you can check it by plugging it back into the original equation. 5 times 2.48 equals 12.4. But your actual answer is that x equals 2.48. Another example. Solve the equation negative 9.3 equals 1.5t. Again, this means 1.5 times t, so to get the t by itself with the coefficient of 1, we're going to divide both sides by 1.5. 1.5 divided by itself is 1. Negative 9.3 divided by 1.5 is negative 6.2. So we get negative 6.2 equals t. Again, do any necessary arithmetic off to the side. We can check our answer if needed by replacing the t with negative 6.2, and it should multiply out to be the same, which it does. Therefore, your answer is negative 6.2 equals t. Objective 3. Solving equations using both properties. We have 2.5b plus 0.35 equals negative 2.65. The b is on the left, and we have to deal with the addition and the multiplication. When you're solving equations, a lot of times you're basically doing the order of operations backwards. So you start with the addition subtraction and then work with the multiplication. So we're going to start by subtracting 3.5 from both sides, or thinking of it as adding a negative 3.5 to both sides. Remember that adding a negative is the same as subtracting. On the left, we get 2.5 plus 0 equals negative 3.00. It's up to you whether you want to maintain those decimals or not. Again, also it's up to you whether you want to have the plus 0. A lot of students choose not to write that. So now we have 2.5b equals negative 3. Remember, adding 0 doesn't do anything. Now to get the b to have a coefficient of 1, we're going to divide both sides by 2.5. 2.5 divided by itself is 1. Negative 3 divided by 2.5 is going to give us negative 1.2. So our answer is b equals negative 1.2. You can check this by plugging it back in the original equation. 2.5 times negative 1.2 is negative 3, plus a negative 3 plus a positive 0.35 gives us a negative 2.65. Therefore, our answer is correct. B equals negative 1.2. Remember, the check is optional. You do not have to do it, and you don't have to show it. And it doesn't actually affect your answer. You're just checking to see if your answer is correct. Another example. Solve the equation 5x minus 0.98 equals 2x plus 0.4. Now we have a variable on both the left side and the right side of the equation. It's up to you what side of the equation you want to get the variable on. However, my goal is always to get the variable to be positive. So I'm going to choose to move the 2x to the other side by subtracting 2x from both sides. The reason I'm choosing to do this is because 5x minus 2x is a positive 3x. Notice how I did nothing with the constants. The negative 0.98 gets copied down, 0.4 gets copied down, but here 5x minus 2x is 3x, and 2x minus 2x is 0. We added a negative 2x to both sides. Add these two together, and if you want to, you can rewrite the subtraction of 0.98 as adding a negative. Again, these two things are interchangeable. Go with whatever one makes the most sense to you. Now we have to get this 3x isolated, so I'm going to add 0.98 to both sides. This is going to cancel and give us 0, and 0.4 plus 0.98 is 1.38. And then recall that 3x plus 0 is simply 3x, and then we're going to get the x to have a coefficient of 1 by dividing both sides by 3, and we get x is 0.46. If we choose to check that, again plug it in for both x's, do the arithmetic, and you should get the same number. Notice though, 1.32 is our answer, 0.46 was our answer. This was simply our check. Lastly, solving an application problem. Many larger airplanes have phones that can be used to call people on the ground. In January of 2004, the cost of using the air-to-ground cell phone was $3.28 per minute, plus $2.99 connection charge. Hernando was billed $19.39 for one call. How many minutes did the call last? First thing is to read the problem, which I have just done. And then, after you've read it, go through and determine what is unknown and what is known. Unknown is the number of minutes the call lasted. This is usually the final question that they ask you at the end of the problem. Notice, how many minutes did the call last? Known are a couple of things. The costs are $3.28 per minute plus a $2.99 connection charge, so just $2.99. And the total cost was $19.39. Step 2 is to assign a variable. In this case, there's only one unknown, so we'll use that be our variable. That unknown was the number of minutes, so we're going to let m be the number of minutes. You must do this. If you do not assign a variable and tell me what the variable is representing, not what it equals, but what it represents in the equation, you will not get full credit. Now we have to write an equation. Sometimes it is helpful to do a hybrid equation using words first and then get into the numbers and symbols. So that is an example of this. I know that my total cost is going to be the cost per minute times the number of minutes. So if I only made one call, or if I only talked for 1 minute, I would only be charged $3.28. If I talked for 2 minutes, I'd be $3.28 plus another $3.28. 3 minutes is a $3.28 plus another $3.28 plus another $3.28. Whenever you are repeatedly adding, you're simply multiplying. So it's the cost per minute times the number of minutes plus that basic connection charge. All of this adds up to be the total cost. Now the cost per minute I know is 3.28. I don't know the number of minutes, that was my variable, so that's my m. The connection charge I know is $2.99, and then my total cost is $19.39. If you struggle with word problems, I highly recommend that you do this hybrid step where you write an equation in words first before you put it fully into symbols. You need to have this equation to get full credit. Once you have the equation, you have to solve it using algebra. So we want to get the m by itself. We're going to start by subtracting $2.99 from both sides, or adding a negative $2.99 to both sides. You can think of it either way. We get 3.28m plus 0 is 16.40. Again, adding m doesn't do anything, so really this is just 3.28m. Sorry, adding 0 doesn't do anything. And then to get the m with a coefficient of 1, we will divide both sides by 3.28, and in this case we get m equals 5. Then you need to make sure you include units in your answers. So the call lasted 5 minutes. I would also highly recommend writing your answer as a complete sentence. That's the best way to make sure that you've included units and really answered the question they asked. And lastly, you should check the answer by plugging it back into some of the original statements to see if it makes sense. If it's 328 per minute times 5, that would be 1640. So that's how much they were charged for the actual minutes. Plus, that additional $2.99 connection charge adds up to our overall total of $19.39. It was billed $19.39 and they match. Therefore, I'm confident that my answer is that the call lasted 5 minutes. That concludes section 5.9. Your next steps are to complete the worksheet for section 5.9, then check the key for the worksheet in D2L, and then do the online homework for section 5.9 in My Math Lab. Lastly, start on section 6.1.